This is the second video for graphing cubic functions. In this video, we will be graphing transformed functions like this. And then we will have a transformed graph and we have to figure out the equation from the graph. So this is what we will cover in this video. Let's start with the first example, 2 parentheses x minus 1 to the power 3 minus 1. Now, in order to be graphing that, let's put that in y equals. Let's get some points to be able to graph it. But before I do that, I would like to discuss what the point of symmetry is and what the transformation is. It's good for us to know those two from the equation. So let's look at the point of symmetry. The point of symmetry for cubic functions is as important as the vertex is for the quadratic and parabola. And just like before, we used to use h and k to find the vertex, we also use h and k to find the point of symmetry. In this case, the h is going to be, remember, the opposite of the number on the inside. So since I have a negative 1 on the inside, the h is going to be plus 1. Now the k is going to be the number on the outside, and the number on the outside is negative 1. So that is going to be my k. So my point of symmetry is going to be 1, negative 1. Now, in order to check whether I'm correct or wrong, once I graph this on the calculator, remember it's the point where the graph curves, and it's going also to be in my table. Now, let's talk about the transformation. A in this case is the number in front of the parentheses. A in this case is a 2. Since A is 2, then I know, let me just fix this. Since A is 2, then this means that there is a vertical stretch. Remember, when A is greater than 1, that means I have a vertical stretch. If A is less than 1, like half or 1/3 or 0.5, then it would be a vertical compression. Now h is 1. It means my graph is going to go to the right 1. K is negative 1. That means my graph is going to go down 1. Okay? Now remember, if h is positive, it means your graph is going to the right. If k is negative, then that means your graph is going to go down. If a is greater than 1, in this case 2, then that's a stretch, a vertical stretch. Now let's put that function into y equals. And then let's go to the table to get some points to be able to graph it. So now let's graph it just to see how it looks and just to check my point of symmetry in a way. Now I can see that it curves at 1, negative 1, so my point of symmetry is correct. And I can also go to the table and make sure that the point of symmetry is there on the table. So I'm correct as well. I didn't just, the point I have written down is actually on the table. Now, for you to graph a cubic function, 3 points are more than enough. Always choose the point of symmetry, which is 1, negative 1 in this case, and then a point above it and a point below it. And these are called like reference points. You don't really need to know this term, but it's good for you to know. So point of symmetry, 1 point above it and 1 point below it. So let's write our graph down, our table. So the table will have the points 0, negative 3, 1, negative 1. If you want to box that, to remember to curve your graph at this point, if you want to do that. And then 2, 1 would be another point. So let's plot these points. So 0, negative 3, and then 1, negative 1, and then 2, 1. Now some of you will tell me, oh, look, I can connect them as a line. But no, it's a cubic function. There's to the power 3, so you do not connect them as a line. You curve your graph at the middle point. So what I'm going to do is I'm going to start by going through the first point, curving my graph and then going down. So that would be an acceptable graph. Okay? Now, as you remember from before, the domain and range will always be all real numbers because it's going on forever. Now, the end behavior is always as x tends to negative infinity. Where would y go? This is what you need to check. So look at negative infinity means look at the left side of your graph. Look at the left side of your graph. Is it going down or up? The left side of my graph is going down, so y is going to negative infinity. Now, as x goes to plus infinity, it means look at the right side of your graph. My right side of the graph is going up, so y is going to plus infinity. Okay? And that's how you do end behavior. Now let's move on to the second question. And then, like we did before, let's think of the point of symmetry and the transformation before we actually graph it. The point of symmetry is going to be h and k. H in this case is going to be opposite of negative 3, so it's going to be 3. And the k in this case, I do not have a k on the outside, so the k is 0. So 3, 0 would be my point of symmetry. So I already know one of the points that's going to be on my table. It's going to be the middle point. Now the transformation, let's look at A. A is negative half. The negative, like we talked about this before, the negative means that there will be a reflection over the x-axis. Now the 2, or the half in this case, show me that there will be a vertical compression, okay? Because it's less than 1. The negative means that there will be a reflection. The h in this case is a 3, so I know that my graph is going to go to the right 3. Okay, so there is a reflection. There's going to be a vertical compression, and then my graph would be going to the right 3. So let's go ahead and plot or graph this. So I'm going to go to y equals, and I'm going to put my new equation, which is negative 1 over 2. Or you know what? You can actually put a fraction by clicking on alpha y equals, pressing enter. Then you have a 1 on top and a 2 on the bottom. Then you move over 1, open parentheses, x minus 3 to the power 3, and then there's no k. So if I graph it, it will give me an idea of how my graph will look like. Okay, it's a reflection, as you can see, instead of going like the usual one, going from here, going through the curve and going down, it's reflected. So that makes sense because it's a negative. It's going through 3, 0, it's curving over here. So yes, that's my point of symmetry. These are all good things to notice. Now let's go to the table. Let's look at the point of symmetry, and that's going to be 3, 0. And then take 1 point above it and 1 point below it. I know there's fractions, so don't freak out. It's okay, it's just a half. So you take the half of the square, it's fine. It's no big deal, okay? So now let's create our table. So our table, it's enough to have 3 points. So the first point is going to be 2 half, so 2 and then 0.5. If you want to put 1, 4, and 5, negative 4, it's okay, it's not wrong. I'm just telling you that 3 points are enough, okay? So 3, 0, and 4 minus or negative 0.5. So let's plot these points, 2.5, 2 and 0.5. So I take the middle of the square on the top, and then I have 3, 0, so that's another point, and then 4, negative 0.5. Now remember, do not connect those as a line. You have to curve it. So I'm going to start with the top, go through this, curve it, and then go down. And that would be my graph. Now let's compare it to the graph that you have on your calculator. And look, does it look similar? So always compare it to double check, okay? Now your domain and range is always going to be from negative infinity to infinity. Like we talked about this before, always going on forever. Now the end behavior, so let's look as x tends to, or goes to plus infinity. Look at the right side of your graph. Where is it going? No, this is not the right side. I'm sorry about that. So the right side is over here. This is my right side. This is the right side of my graph. It's going down. So y goes to negative infinity. Now, as x goes to negative infinity, means look at the left side of your graph. As you can see, it's going up, the left side of the graph. So that's the point of symmetry. This is the right of the graph, and this is the left of the graph. The right is going down. The right means x going to plus infinity and y going to negative infinity since it's going down. As x going to negative infinity, it means look at the left. Your graph is going up, so the y is going to plus infinity. And that would be the end behavior. This is how you graph transformed forms. Okay? Now, let's move on to the third and the fourth part, which is basically, or the third part, which is basically you are given a graph and you need to come up with the equation. Now, the most important part of the graph, like we talked about before, is going to be the point of symmetry. So the point of symmetry is where the curving is occurring. In this case, 2, 1 is my point of symmetry. And like we talked before, this is going to be my h is 2, and my k is going to be 1. Okay? Now, the a is something I can actually count for. So if you look back at the graph, start with the point of symmetry and go to the reference point, one of the reference points, okay? It's just like slope, okay? So it's basically counting 1, 2, 3 up. So that means that my a is 3. If you want to count down, you can do that, okay? So 1, 2, 3. So a is actually 3. Now, how would you know if it's a positive 3 or a negative 3? Remember, if the graph is like that, it's going like from this side and then going down like that, then that would be a positive. But if it's starting on the opposite side, remember, so if the graph starts here, curves through the point of symmetry and then goes down, that would be a negative. So basically, if it looks reflected, this is how you know that it's a negative a, okay? Now the a, you count from the point of symmetry to one of the points over there in your graph, okay? So now once I found a, h, and k, I can just plug them in. So y equals, the a is 3, and then x, remember for the h you always take the opposite. Since it's 2, I put a negative 2 inside the parentheses to the power 3, and then I put the k as it is. The k is plus 1, so I just put plus 1. Now let's move on to the second part, or the second one. The point of symmetry in this case is negative 2, negative 2. That means my h is negative 2 and my k is negative 2. To find a, I need to count from the point of symmetry to one of the points on the graph. So let's count. 1, 2, 3. A in this case is 3 as well. Now let's go ahead and plug it in our equation. So y is equal a, and then x, remember the h, you have to take the opposite. Since h is negative 2, so you put plus 2 to the power 3. And don't forget the k, and the k in this case is minus 2. Okay? And this is how you write the equation from the graph. Don't forget to do the practice sheet to understand this lesson better.